So now I'm going to talk you through the eras associated with the Big Bang Theory and the overall unfolding of space and time of our universe. And we'll start out with the Planck era, and that is actually the era closest to the Big Bang, and there's a little bit of uncertainty as to what happened from the time of the Big Bang to 1 × 10⁻43 seconds. So very, 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 very close to the Big Bang. There's no solid theory. Now, I say that, and others might argue, but I'm going with what your textbook said. So after the Planck era comes the gut era. And you might remember that the gut force actually is where we had 3 forces unified, and 1 force, gravity, was not part of that. So at the gut era, though, finally, now this would be 1 × 10⁻43 seconds after the Big Bang, and you can see it ends at 1 × 10⁻38 seconds. You can see the universe is still very, very, very hot. And so actually, this is the era, at the gut era, that we have gravity being distinct in our universe. At the end of the gut era, then we have the strong force breaking out away from the weak and the electromagnetic. So we have the electroweak force, the strong force, and the force of gravity. Also associated with the next era is what we have, something called inflation. Before I get to that, the electroweak era, as I mentioned, it follows the gut era, and we have the strong force breaking away from the electromagnetic and the weak force. And associated with this era is something called inflation, which is kind of an important part of the Big Bang Theory. Then finally, the universe has cooled down sufficient to give us some particles. Okay, so the time frame for the particle era, you can kind of see it listed there. And so the universe is cooling down. At this time, we finally have, in the particle era, we have 4 forces. The forces are not uniform. They're all unique, just as we have today: the strong force, the weak force, the electromagnetic force, and the force of gravity. So in the particle era, one of the things that I think is amazing, and I've listened to those documentaries on the History Channel, maybe like you have, and heard astrophysicists just talk about how very cool this is. Just like in Star Trek, when they talk about matter and antimatter, it's a real thing. And so when matter and antimatter come in contact with each other, they annihilate each other. And so actually early on in the universe, in this particle era, we had matter and antimatter that would annihilate each other. They'd come into existence and they would annihilate each other. And for every, down here, 10 to the 9th, so that's 1 billion, for every 1 billion pairs of matter and antimatter that annihilated each other, you would have 1 particle in that 1 billion particles of pairs, 1 particle of regular matter that would survive. And so actually that's how we got our matter built up. Isn't that amazing? Our regular matter built up. So it was still pretty darn hot. After the particle era, we have we're cooling down to what we call the era of nucleosynthesis. And so in this era, the temperature and density actually begins to, mostly the temperature, begins to allow for the formation of nuclei. But then we have the full-fledged era of nuclei some 5 minutes after the Big Bang, outwards to 380,000 years after the Big Bang. And the era of nuclei, we have a lot of hydrogen nuclei. Actually, in some of the cases, this hydrogen was what we call these days heavy hydrogen, deuterium nuclei. And we had a certain amount of helium also formed, helium nuclei formed in this period of 5 minutes to 380,000 years after the Big Bang. Now, what we know about the structure of an atom today is that the nuclei is just the inside of the atom. And so what the nuclei has are protons and neutrons, but the nuclei still needs electrons to make it an atom as we know it today. And so finally, after 380,000 years, we finally have the temperature cool down to the point where electrons can now go ahead and associate with nuclei. And this actually was a milestone in our universe, because when those electrons finally kind of settled down and became associated with nuclei, then our universe kind of cleared up with regard to energy being able to move around freely, and for us to be able to see past kind of this fog of this haze, this chaos that was created by, prior to that time. So after the era of atoms, we have the era of galaxies. So it wasn't until about 1 billion years or so after the Big Bang were the temperatures cool enough, sufficiently cool, for stars within those protogalactic clouds to go ahead and come alive. Within the stars, we had nuclear fusion. So the era of galaxies begins 1 billion years to present day. And here's my little hint down here to remind you that I have all sorts of videos. I have a playlist of videos associated with Chapter 17 available from the course home page, because there are so many things that you can get out on YouTube to reinforce what we're learning in this chapter.